In this video, we're going to talk about angle bisectors and triangles and just the different properties that are created by them. So first, let's review what an angle bisector is. So it's a ray that divides our angle into two congruent adjacent angles. The angle bisector theorem is more specific, so if you look at our picture right here, you can see that AD is the ray and it is bisecting angle BAC. Point D is on the bisector of the angle, and that point D, since it's perpendicular to the edges of the sides of our angle, that those are going to be congruent or equidistant from the two sides of the angle. So there's a couple things I wrote down right here. So we see that AD is the angle bisector, it's the ray AD. So that means that BD is congruent to DC, and I put my markers in there for congruence. But one thing that has to be in there is that they have to be perpendicular to the edge of the side of the angle. If those perpendicular symbols were not there, then BD would not necessarily have to be congruent to DC. So next, the converse is, remember that's the opposite order, so we're going to first start with that our point is in the interior of the angle and it is equidistant from the sides, so that's what you can see that we do start off with, and then because we know that, then we know that AD is going to be our angle bisector, so that means that point D then would be on the angle bisector. In this picture you can see that we're trying to find the angle of GFJ. So GFJ is this missing one right here. We can see the 42 degrees. We can see that GH is congruent to JG and that it's perpendicular. So because we have that it's the same distance away from the sides of the angle and the perpendicular, we know then that point J has to be on the angle bisector. So this measure of this angle also has to be 42 degrees. In this next one, we know that the only way that our point P will be on the angle bisector is if it is the same distance to the sides of the angle, so point B and point C, and they have to be perpendicular. So these two segments need to be equal to each other. So we need to set x plus 3 equal to 2x minus 1. Alright, so go ahead, push pause, work it out, and then check your answer against mine. Alright, so first off, if we subtract the 1x from the left-hand side, we get 3 equals x minus 1, and then you add 1 to the left side, so I get x equals 4. So, when x equals 4, then point P is on our angle bisector of angle A. Alright, I would like you to try all three of these questions. So we're going to number them as 1, 2, and 3. So go ahead, push pause, work out all three of them, and then when you're ready to check your answer, push play. We can check your answers together. Alright, in this first one, since we see that our angles are bisected, then that means that x and 15 have to be equal to each other, and then there's your x values, x equals 15. The next one, because the point over here at the end is the same distance away from the edges of the triangle, or the edges of the angle, sorry, so that means that these two angle measurements would have to be congruent to each other. So 3x plus 5 equals 4x minus 6. When I solve for x, I can move the 3x to the right. This gives me 5 equals x minus 6. Then I can move my x to the right by adding 6 to both sides. And we get x equals 11. So the last problem, because it is an angle bisector, then that means that this point way up here should be the same distance to the edge of my angle, so both of these should be equal to each other. So we should set up 5x equals 6x minus 5. Then if we move this 6x to the left-hand side, otherwise we're not going to have anything over there, so we'd have a negative 1x equals negative 5. Divide everything by negative 1, so we get x equals a positive 5. So for the next question, do we have enough information to say that point S, or QS, right, QS is the angle bisector? And if you look at it, we see that they are congruent to both sides of the angle, but the biggest thing that is missing is that it's not perpendicular to the sides. So this QS may not necessarily be down the center. This is where the point of concurrency comes in. So with angle bisectors, where three angle bisectors intersect, it will always be inside the triangle, and it's called the incenter. So the concurrency of angle bisectors in a triangle, the angle bisectors intersect at a point that is equidistant from the sides of the triangle. So if you look at our picture, the red lines are the angle bisectors, and then these blue lines are where it connects it to the sides of the triangle. So those three pieces are congruent to each other. So you might want to color code your picture so you know which is which. Then the point P is called the point of concurrency, and for angle bisectors, that point is called the incenter. And this point will always be inside the triangle, never on the outside like some other cases are. So if you can see my picture here on the right or up above, you can see that if we have three angle bisectors, the point of concurrency is right here in the center. This is the incenter, and it is the same distance to all three sides in the triangles. There's one right there, there's another one right here, and another one right here. So all three of those are congruent to each other. And if you notice that the radius of that circle is also going to be the same all the way around, which is why that circle is inscribed within the triangle. That's what it's called. So in this first problem, we have that N is the incenter. So if you see with the color coding again, that these blue lines are all going to be congruent to each other. And they tell us that the 16 is AF and the 20 is the AN. And we need to figure out what the length of ND is. Well, if you notice that this third side in that right triangle is going to be the same size as ND, so if we find NF, then technically we've already found ND. So if we have a right triangle where we have one side is 16, the hypotenuse is 20, we can use Pythagorean theorem to find what that third side is going to be. So I'm going to use my X as my A, my B will be my 16, and then my C will be my 20. So when I solve this, I get x squared plus 256 equals 400. When I subtract that over, I get x squared equals 144. And when I take the square root of that, since that will give me my actual x value, then I will get x equals 12. So NF equals 12, but since that is congruent to our ND, then ND will also be equal to 12. So I want you to try the same thing, similar picture, but I'm giving you different measurements to start with. And again, I want you to find what the ND measurement is. So go ahead, push pause, work it out. You may need to use this Pythagorean theorem idea in drawing a separate triangle out to the side. And then when you're ready to check your answer, go ahead, push play. So in this picture, we need to find NF with my right triangle. And then once we find that, that is the same distance as ND. So my triangle that we have is the 12, I'm going to put that as the x of my NF, and 13 is my hypotenuse again. So this is what you should have set up, and when you simplify, we get x squared plus 144 equals 169. When I subtract the 144 over, I get 25. So when I solve for x, I get 5. So my NF is equal to 5. Right there, but we know that ND is going to be congruent to it, so ND is also equal to 5.